All right, you guys, first thing we need to do is graph it. Okay, so we've got our y-axis and our real axes, right? So this is like the coordinate point 6, 4 right here. It's in the order of it. And we're going to plot that point. So we're going to go right 6, up 4. And we always connect to the origin and back to the x-axis. So I went right 6, and I went up 4. And the whole thing is to go into cis form right here. So it's always r cosine I sine theta. So r is the length of this hypotenuse right here. And the angle is the angle from the positive x-axis over. We're in quadrant 1 on this one, so we won't have to like add 180 or subtract 180 or anything when we find that. So to find r, we are going to do what? Pythagorean theorem. So I do 6 squared plus 4 squared equals, if you want to call that r squared, that's fine. And I get 36 plus 16, which is 52. And we square root it, so we get the square root of 52. You can put it as a decimal. Just make sure that you keep that exact number when you do the rest of the problem, right? Like highlight that number so that you're using the whole thing. Or write square root of 52. Cosine, I sine. And now I need theta. You can really use any trig function, but I recommend tangent. The reason that I recommend tangent is because if you use the hypotenuse, you might have messed it up. So at least use what you started with, and then you'd be good to go. So to find this angle, tangent is opposite over adjacent. So I just can write tangent theta is 4 over 6. And yes, we're going to do inverse tan to solve, and some people don't show this step because we've done a lot of these. That's okay. But inverse tangent gets my angle by itself. And we get the angle 33.690 degrees. So I'm going to write that right here, 33.690 degrees. But we are finding the 4/4 roots. So I want 4 answers, and I want 4th roots, which means I'm taking this whole entire thing to the 1/4 power. And de Moivre's theorem tells us that we take this number to the 1/4 power, and we divide this number by 4, right? Ever remember that? Good. So when you take this square root of 52 to the 1/4, you get 1.639. Again, make sure if you did take the square root of 52 that you don't round ahead of time, right? Use the whole entire number when you plug it into your calculator to the 1/4 power. And divide this right here, we get 8.423 degrees. Now, if you're doing the 4/4 roots, how many answers are there? This is your first answer. And so to find the other ones, we do 360 divided by 4, which is 90. And we're going to add 90 every time to get the rest of my answers. So I keep my same number here, and we're going to add 90. So I get 98.423. And then I add 90 again, and I get 188.423. And I add 90 again, and I get 278.423. Those numbers right here, these numbers should always be between 0 and 360, right? So this means the same thing as the sentence, find the, what? 5/5 roots. Right? So this could be written as find the 5/5 roots of -17 minus 14i, right? So we're going to do the same thing. We're going to draw a graph first. And so this is the coordinate point -17, -14. So we're down here in quadrant 3. We're going to connect it to the origin, and we're going to connect it to the x-axis. And this is a distance here of 17 and a distance here of 14. I don't necessarily have to write negative 17, negative 14. If you do, it's not wrong. Just notice that your angle is positive when you do your tangent. All right, Pythagorean theorem gives us, so if I just do 14 squared plus 17 squared, I can get my R value, which ends up being 22.023. So I have 22.023 cosine I sine. Now, be careful here. When we do our tangent, we're going to say, everyone good with me just saying inverse tangent and not writing tangent theta? Means same thing, okay? So inverse tangent of opposite over adjacent, so that's 14 over 17, gives me just the reference angle, right? So just the angle inside. That's actually 39.473 degrees right here. But when I'm in cosine I sine form, where do I need to start my rotation? The positive x-axis, yep, all the way over. So what do I need to add here if I'm in quadrant 3? Yeah, so I'm going to add 180 degrees, and that's going to give me 219.472 degrees. All right, so now I need to find the 5/5 roots. So I'm going to take this whole entire thing to the 1/5 power. And this first one we plug into our calculator, but you guys, don't use this number. Be sure you actually use the entire forever decimal. Everybody good with that? I don't need to show you how to do that. You would just keep this answer, you'd add 180, and you'd keep that answer, and then you do that to the 1/5 power. So this to the 1/5 is 1.856. And what do I do here? Divide by 5, and I get 43.895. And then we need all 5 answers. This is the first one, so I'm going to take 360 and divide by 5, which is 72. And I'm going to add 72 until I'm done. So I have 1.656 cosine I sine, 115.8. And I get 1.856 cosine I sine, 187.894. Okay, so I added 72 every single time, and all those angle measures should be between 0 and 360. That's really small, but does this say, or are we finding roots in this one? No. So how many answers are we going to have in our final answer here?
1.
Yep, there is only one answer. So let's graph this one. So I'm going right 1 on the real axes and down the square root of 3. So it's positive and then it's negative, about right here. Connect it to the origin and to the x-axis. So this distance is 1. This distance is negative root 3, but I'm going to go ahead and put root 3 since it's a distance. Some of you might already know what the other side is because we've done this one so many times, but you could do Pythagorean theorem. What'd you say? 1 root 3, 2? What'd you get? Try that again. Try again. 1 squared is 1. Square root of 3 is 3. 4. Oh. I get you. I thought you were telling me the answer was like 1 root 3, 2 or something weird. Okay, I got you. So anyways, it is 2 for the radius here. And so that means I have 2 cosine I sine. We need to find this angle. Again, this is a special right triangle, so you might just know that angle, but if you don't, you can still use inverse tangent. But if this was a no calculator problem, then you would need to know the inverse tangent of the square root of 3. Where's the tangent square root of 3? 60 degrees. Okay, so I know that's 60 degrees. But to be in cosine and sine form, we need from the positive x-axis all the way over. If you're in quadrant 4, that means you do 360 minus the reference angle. So this is 300 degrees. And then we need to do this whole thing to the 6th power. All I did was change this form to cosine sine form. So now I got to go to the 6th. And again, de Moivre says that we do 2 to the 6th cosine sine, and we multiply the 6 by the 300. And you could just leave this as 2 to the 6, and you get 1800. Now, is 1800 between 0 and 360? No. So you got to subtract 360 a bunch of times until you get within the range, or you could just know this goes in evenly, which is neat, and we get 0 degrees.